In this problem, we're going to list the possible rational zeros for the polynomial q of x is equal to x to the fourth minus 3x cubed minus 7x plus 6. To do this, we're going to use the rational zeros theorem, which says we can take the constant term, so that's the term that does not have an x, and we can take all the factors of that and divide by all the factors of the largest degree term, and this will give us all of our possible rational zeros. So the way that we do this is we start with our constant term, so that's 6, and we think of all of the factors of 6. So we have 1, 2, 3, and 6. Those are the only things that divide 6. Now let's look at the degree, the term with largest degree, which is x to the fourth. The coefficient of x to the fourth, though, is just 1. So we want to think of all of the factors of 1, and that's just 1. So what we can do with each of these is actually make them positive or negative. So we say this with a plus or a minus. And the reason we do this is because for any factor you get of a number, its negative is also a factor. So think about it like this. You could say 2 times 3 is 6, but you could also say negative 2 times negative 3 is 6. So that way you get the positive and the negative numbers. So the way that we get our possible rational zeros is we just take everything in the top row over everything in the bottom row in every single combination. So we can have plus or minus 1 divided by plus or minus 1. We can have plus or minus 2 divided by plus or minus 1. Plus or minus 3 divided by plus or minus 1, and plus or minus 6 divided by plus or minus 1. So all we have left to do now is just simplify these fractions. So 1 divided by 1 is just 1, so our first possible zero is plus or minus 1. 2 divided by 1 is 2, so our second possible zero is plus or minus 2. Third possible, we have 3 divided by 1 gives us plus or minus 3. And then 6 divided by 1 gives us plus or minus 6. So our possible rational zeros are these 8 numbers. So keep in mind that these are just possible zeros. That doesn't mean that these are actually zeros, but these are all the ones we have to choose from. Next, we're going to actually find the zeros and write in factored form. So not only are we finding the possible zeros, but we have to actually check and see which ones work. So for this first example, we have p of x is equal to x cubed plus 3x squared minus 4. So we'll start by finding the possible rational zeros. And remember, we do this by looking at the constant term and by looking at the term with highest degree. So if we start with our constant term, we have 4, and the factors of 4 are plus or minus 1, plus or minus 2, and plus or minus 4. Then we look at the term of highest degree, and the coefficient of x cubed is 1, so the only factor of 1 is plus or minus 1. So our possible, so notice possible rational zeros, not actual but possible, are the following. We have plus or minus 1, plus or minus 2, and plus or minus 4. So we have 6 numbers that we need to check. Now, you don't have to check all 6 necessarily. Once you find one that works, then you can simplify your equation down and you don't have to use this rational zeros theorem again. So maybe let's start by checking 1. So the way that we check a zero is we use synthetic division. So we're just going to take our polynomial. So we have 1, 3, 0, negative 4. And we're going to divide it by 1. So we're going to set up that synthetic division. Okay, so the way we do synthetic division, we bring down the first number, multiply through by the number in the box, and write it under the second number. Add going down, so 3 plus 1 is 4, and then we repeat the process. So 1 times 4 is 4, 0 plus 4 is 4, 1 times 4 is 4, and 4 minus 4 is 0. So this is what we want. So once you get a synthetic division problem that gives you a 0 in your remainder spot, you know that you found a 0 of your polynomial. So in this case, we know that 1 is a 0. So this synthetic division tells us that 1 is a 0. So I'm just writing that out so you have what I am saying. So now let's translate this synthetic division answer back into a polynomial. So we know that we stepped down 1 degree, so our answer should have x squared, and then we'll have a plus 4x and a plus 4. So this is once we divided the p of x by x minus 1. So let's maybe translate that into a polynomial as well. So this is basically what we did with synthetic division. So we took our original p of x and we took out a factor of x minus 1, and it left us with x squared plus 4x minus 4. So the question now is, can we factor down x squared plus 4x plus 4 even further? And the answer is yes. So we still have our factor of x minus 1. Again, that's the one that got taken out because of synthetic division. And then we can split up x squared plus 4x plus 4 into 2 other factors. So the only way we can split up x squared is to write an x in each factor. And now we think of 2 numbers that multiply to give 4, but also add to give 4. So there's really only a couple of ways to do this, and only one that's going to actually add to 4. Excuse me. Sorry about that. So the only way that this is going to work is if we choose positive 2 and positive 2. So x squared plus 4x plus 4 breaks down into 2 identical factors of x plus 2. So now we actually have p of x in its factored form. Okay, so this is the factored form. And our zeros are all of the numbers that correspond to each factor. So we already knew that a 0 was positive 1. That was from the synthetic division. From the remaining factors, they're identical, so we're going to get the same 0 back for both of them. So we're just going to write this once. So x plus 2 gives us the 0, negative 2. And x plus 2 and x plus 2 are the same factor. So our only 2 zeros are 1 and negative 2. Let's try this again in a slightly different way with the next problem. So in this one we have p of x is equal to x to the 4th minus 10x squared plus 9. So many times the rational zeros theorem is the only way to do these problems. However, there are a few exceptions. So in this case, this problem actually factors a lot easier than it is to maybe check all of the rational zeros. So if we think about this polynomial, so we have p of x is equal to x to the 4th minus 10x squared plus 9, we can think about this sort of like a quadratic. So a quadratic just means that your polynomial has degree 2. So that means your biggest term is x squared. Well, here we have x to the 4th. So it sort of behaves the same way. So we want to think of a way to factor this. So we'll get 2 identical factors, and really the only way to break up x to the 4th nicely is to say x squared goes in one factor and x squared goes in the other factor. And now we want to think of 2 numbers that multiply to give us 9 but add to give us negative 10. Well, 9 and 1 do that trick. So if we put negative 9 in one factor and negative 1 in the other factor, that will give us our desired factorization. Now we can ask ourselves if we can factor this further. So each of these factors that I have written here is what we call a difference of squares. And that's a special factoring pattern that you should have seen before, maybe in high school, maybe not. If not, we're going to go over it right here. So when you have a difference of squares, so that means like a squared minus b squared, so like if you have a perfect square minus a perfect square, we can always factor that as a plus b times a minus b. Okay, so this is just sort of like a thought bubble off to the side, like that. Okay, so we're going to use this idea to factor each of these two factors, x squared minus 9 and x squared minus 1. We're going to use that to factor them down a little further. So x squared minus 9, we can factor into x minus 3 times x plus 3. X squared minus 1, we can factor into x minus 1 times x plus 1. And now what I have is 4 factors that I cannot factor down any further. So now, this is my factored form of p of x. So sometimes it is easier to get the factored form first before you find zeros. So this is our factored form. And now let's find the zeros. So to find the zeros from a factor, what you can do is set each factor equal to 0. So we can set x minus 3 equal to 0, x plus 3 equal to 0, x minus 1 equal to 0, and x plus 1 equal to 0. And when we solve each of these little bitty equations, we're going to come up with an answer for x that will be our 0. So for the first one, if we add 3 to both sides, we get x is equal to positive 3. For the second one, if we subtract 3 from both sides, we get x is equal to negative 3. For the third one, we can add 1 to both sides, and we get x is equal to 1. And for the last one, we can subtract 1 from both sides and get x is equal to negative 1. Now, these are the 4 zeros of our polynomial. So the zeros we would list like this. We would say 3, negative 3, 1, and negative 1. Okay, so those are our 4 zeros. When you're doing your problems in WebAssign, though, just pay very, very close attention to the directions. So sometimes they may want you to list your zeros in a particular numerical order, or maybe they want you to write a 0 twice if you have 2 identical factors. So just pay really, really close attention to the directions in WebAssign.